Alright, so let's go ahead and talk about motion diagrams. A motion diagram is a vector diagram that describes the motion of an object. So the rule of thumb for me, and they're different depending on which textbook you look at or which person you're talking to. But what I like to do is I like to have 3 velocity vectors and I like to have 1 acceleration vector. I don't draw any position vectors at all or displacement vectors. I just have velocity and acceleration. Now, here's the rule of thumb. You draw them to scale. So let's go ahead and put that up here. So when you're doing this, you're going to draw them to scale. The next thing you want to do is I always use red for velocity. And I use purple for the acceleration. Okay? And again, you're going to have 3 velocity vectors. And you're going to have 1 acceleration vector. And I'm going to go ahead and change the size of all this so you can see it all. Okay? So, you draw it to scale with a ruler. You're going to use red for velocity, purple for acceleration. You're going to have 3 velocity vectors, and you're going to have 1 acceleration vector. So let's go ahead and do an example. We have a car that's slowing down while traveling east. Okay, if it's slowing down, that means it's accelerating. And since it's going east, we know our velocity vectors are going to be pointing to the right. So let's start out with the velocity vectors. If we're slowing down, that means they're getting smaller and smaller for each time interval. Okay, so the first thing I'm going to do is I'm going to start out by drawing my first velocity vector. And here's my ruler. So I'm going to make my first velocity vector, I'm going to make that 4 centimeters long. And again, we're going to make it red. The next velocity I'm going to draw, I'm going to make it 1 centimeter shorter. Okay, so I'm going to start here, and I'm going to make it 1, 2, 3. So that's 3 centimeters long. This one's 4 centimeters, this one's 3 centimeters. Notice that I don't have them touching. When you draw your velocity vectors, you should be drawing them tip to tail. When you're adding them. We're not adding these, we're just drawing them. And then the next one is going to be 2. Okay, so this is 4 centimeters, this is 3 centimeters, this is 2. Oops, that's not 2. This is supposed to be 2 centimeters long. Okay? So now that I've drawn my velocity vectors, I'm going to label them. So there's my velocity vectors. And I'm going to make these red. Okay, so all my writing is in red. Now what I'm going to do is I'm going to draw my acceleration vectors. Notice that this is shorter than this. We define acceleration as final minus initial. Final minus initial is going to give me a negative number. And that means that I'm going to draw my acceleration vector going in the opposite direction. And how long should I make it? I'm going to make it 1 centimeter because that's the amount I decrease for every time interval. Okay, and so when I write acceleration, I'm going to write it in purple. Okay, so that's my first motion diagram. 3 velocity vectors, 1 acceleration vector. Check. 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 Purple for acceleration. Red for velocity. Check. And I drew it to scale. Okay, so let's go ahead and try another one. We have a car slowing down while going west. Okay, so now what I'm going to do is I'm going to get out my ruler. So there's my ruler. And now what I'm going to do is I'm going to draw my velocity vectors going west, and I'm going to draw them getting smaller because I'm slowing down. So I'm going to start out by drawing my first velocity vector 4 long, and then I'm going to draw the next one 3 long, and then I'm going to draw the next one, oops, I'm going to draw the next one 2 long. I'm missing one. Okay, so we're going to draw this one, 3, and then we're going to draw the next one, 2. Okay, and so those are my velocity vectors, and I label them V. Now my acceleration has to go in the opposite direction. Why? Because it's final minus initial, and that's going to give me a negative number. Okay, and that gives me 1 centimeter going in the opposite direction, and I'm going to label that A with a vector sign. Okay, so there's my my motion diagram. Now, the reason I've done this is a lot of people say to me, oh, well, if it's going to the right, the acceleration is speeding up, and if it's going to the left, then it's slowing down. But that's not true. Look at this diagram. What is the direction of my acceleration? That's right, it's going to the right. It's going east. What is my overall direction of motion? West. Okay, am I speeding up? No, I'm actually slowing down, going west. So you cannot say that just because I'm going east, I'm speeding up, and just because I'm going west, I'm slowing down when it comes to acceleration. Here's the rule. Look, if I show you the previous diagram, what do you see? You see the velocity vectors going east and the acceleration going west. Now look. The velocity vectors are going west and the acceleration is going east. If I'm slowing down, my acceleration is in the opposite direction of my motion. Okay? You could possibly say that's against your motion. Okay? Because that's really what an acceleration is, right? It's something that causes you to slow down. Okay, so let's do another one. Let's have a car speed up while going east. Okay, so we're going to get out our ruler. So there's my ruler. And now what I'm going to do is I'm going to draw my velocity vectors in red, and I'm going to make them go east. I'm speeding up, so I'm going to start with 1 centimeter, then I'm going to go to 2 centimeters, and then I'm going to go to 3 centimeters. Okay, so there's my velocity speeding up while going east. Okay, so what is the direction of my acceleration? Well, I'm speeding up, so my final minus my initial is going to be a positive value. And that means that my acceleration is going in the same direction. Okay, so there you go. That's your motion diagram for a car speeding up while traveling east. Now, what would it be if I were traveling at a constant velocity? I'm not sure if that's the next one. Let's see. Nope, we're going in the equations. Okay, so let's go ahead and add one. What if I'm going at a constant velocity? Okay, so the first thing I'm going to do is I'm going to get my ruler. Okay, and now what I'm going to do is draw my velocity vectors, and I'm going to make them 2 centimeters long. Notice that the same length for each time interval. Okay, label that V. Now, what's my acceleration? It's actually going to be a dot. We call that a null vector. Okay? We call that a null vector. Final minus initial gives me 0. So there you go. You just get a dot. You don't get a line with a length. Okay, so that's it for motion diagrams. I hope this has been informative, and I hope to see a lot of motion diagrams in your work.